All right, so we've got one more example, and I actually am going to bring this over a little bit so you can kind of see, because actually I'll just redraw it. My graph is covered up by this fantastic video, so that's my fault. I will redraw it. So here's my function. F of x equals 3 over 4x, which actually by redrawing it allows me to talk about the fact that this is basically from the family of 1 over x, where x is a -1, which was a graph that looked like this back from Algebra 2. And remember, it has asymptotes here because I can't put a 0 in the bottom because you can't divide by 0, and because the degree of the denominator is 1 more than the degree of the top, the horizontal asymptote is 0. So what I want to do is use this function to find the equation of the derivative so I can find the slope anywhere on this curve. So notice that at x equals 0 there should be no derivative because there is no function. But these derivatives are all going down. These slopes are all going down, so I should have a negative derivative, as are these slopes. So let's give this thing a go. It's a little more complicated because it's a rational function, but I got to put that x plus h right down here in the bottom. So again, I start with my limit as h approaches 0, and I'm going to put in x plus h right here. So I am not enjoying this red, so I'm going to change this to 3 over 4, and I plug in x plus h. Minus, boom, f of x. This is f of x. So 3 over 4. And all of that is over, and I'm going to change this to a different color so we recognize I now have a rational expression in the top of another rational expression. So I'm going to simplify this first. I need a common denominator, and actually I should have an x down here because the function is 3 over 4x, so that's f of x. Notice that they both already have a 4 in common, so neither of them need a 4, but this side would need an x plus h so that it has exactly what this side has, and this side would need an x. So I'm going to put it in the front just because it's easier for me to place it there. So now my denominator here is set, so I'm going to keep going. This is, again, I know that bottom h has to cancel out somehow. So this gives me 3x minus, and this is minus 3, so if I distribute that there, I get minus 3x. And if I, again, that's a negative 3, if I pop that into both of these, it would be minus 3h. That is all over my common denominator of 4x, x plus h. Doesn't look very friendly. And this is where I switch colors because that's all over h. So I'm going to clean this up first before I clean up this blue denominator. So I have the limit as h approaches 0. And again, notice 3x minus 3x, those cancel. This still has a negative 3h. That's very important that that minus 3 gets distributed, and you recognize that turns that to a negative 3h. This part hasn't changed, 4x times x plus h. And again, I will switch, and then this is where I'm going to clean this up, all over h. But this is really all over h over 1, so that I can look at the fact that I have a fraction divided by another fraction, and dividing fractions is the same as multiplying by the reciprocal. So if I turn the reciprocal of that, divided by h over 1 is the same as times 1 over h. So that in essence has gotten rid of this fraction, and it put the h down here, which notice that h is still in the denominator, cannot put a 0 in there, but here's an h right here, so those h's cancel, and so now I'm sitting with limit as h approaches 0, and I've got a negative 3 up top, and I have a 4x times x plus h, and I don't see anything else I can do, so this is where I take the limiting process and I put a 0 right there. And if I put a 0 right there, this function would equal negative 3 over 4x times x, which is 4x squared, and that is my derivative function. That would give me the slope at any point on this curve. So notice that it has a negative in front, and this is squared, so no matter what x value I plug in, the result will be a negative slope because this function is always decreasing. So the question in your notes is, well, what is the actual slope at 2? So if I plug 2 into this function here, I'll get negative 3. If I put 2 in here, it'll be 2 squared, which is 4. 4 times 4 is 16. So at 2, 1, 2, right there, I have a slope of negative 3/16. That's pretty shallow slope. It's not very steep at all, and that's because this thing levels off at the horizontal asymptote the farther to the right you go. So the larger x values you're going to plug in here, the less steep the slope is going to be. And notice if I were to put in like a half, if I put a half in down here, it's going to create a much steeper slope. But again, I could put any x value in and I could find the slope right here if I wanted to at -1. And pretend like that's a -1. So if I wanted to find the slope at -1, I put a -1 down here. -1 squared is 1. And so my slope would be -3/4. So again, negative slope going down, much steeper than this one, but it's not even equal to -1. It's still a pretty shallow slope. So again, this function right here is my derivative function. And the only thing I'm going to do is I'm going to go to a new page. I'm just going to show you a little trick. So our original function earlier was x squared, and the derivative was 2x. This function was 3/4x, which is the same as 3/4 x to the -1. And the derivative, if we remember correctly, was -3/4x squared, which is the same as saying -3/4x to the -2. So we are going to start looking for patterns as we find derivatives to see if we can algebraically figure out how to go from here to here and how to go from this function to this function without doing this limiting process. There you go. That's example 2. I think you have one to try also. Good luck.